Welcome back, our dear learners, and thanks for watching, thanks for following. Continue to download, because that is one way of how you can access our work. The app is QuestLift on Google Play Store. Now, we are talking pure mathematics, and the topic today is none other than analysis. It is none other than analysis. Now, analysis is subdivided into two subtopics. One of them is differentiation and its applications. The other one is integration and its applications. We are going to look at that later on. Today we are talking differentiation. I've said differentiation and its applications, but someone may ask, differentiation in daily life, where do we apply them? We are going to start with applications. Life applications of differentiation. Life applications of differentiation. And one of them we're talking, it is used to determine the maximum or minimum values of particular functions. Say, I've said it is used to determine the minimum or maximum values of particular functions e.g. cost, strength, amount of material to be used, maybe in construction, and in economics, we can use it to determine a firm's performance in line with profit and loss. Look here. We are talking real life applications. And I've said that it can be used to determine the minimum or maximum values of particular functions. E.g., it can be cost, it can be, in other words, when companies manufacture products, they base on differentiation to determine or to come up with a costing. It can be used to determine strength. It can be used to determine the amount of material to be used, maybe in construction, assuming you have a square plot of land and you want to enclose it with a barbed wire. You want to make a fence of barbed wire. Determining how much you need to buy, you can basically use differentiation to determine that. And the other application is in economic terms, using profit and loss to determine the performance of a farm. It can also be used to check temperature variations. It can also be used to check temperature variations. So be used to check temperature variations. So the topic is analysis. I've said subdivided into two topics or subtopics. One of them is differentiation, and we are talking differentiation. I've started with looking at how is it important in real life. How is it important in real life? Now, talking differentiation, the core to start with is the gradient of a curve. The gradient of a curve. The gradient of a curve. Now, consider a curve y is equal to fx. Consider a curve y is equal to fx with closed coordinates. With closed coordinates. The closed coordinates a x y and b and b, this one is x plus delta x, comma y plus delta y, y plus delta y. So we're going to come up with some simple sketch of our curve. Some simple sketch of our curve. We are talking closed coordinates. This is the curve y is equal to fx. With the closed coordinates, there is and another one here. They are close to each other. This is, if this is x plus delta x, remember the coordinates of b, and this one is x. So corresponding to this we have y, and the one corresponding to this we have y plus delta y. We have y plus delta y. So from there we are talking gradient of a curve. Since A is very close to B, since A is very close to B, then AB can be, thought of as a straight line. AB can be thought of as a straight line. and therefore the gradient of AB for the gradient of AB can be given by I have now, since we are talking straight lines, that gradient M, we know it is change in y over change in x. Please, this is a curve, but I've said that since point A and point B are very close to one another, then AB, that is the line AB, is thought of as a straight line. In other words, joining A to B, we can think of it as a straight line. So if we think of it as a straight line, we have what we call the gradient of line AB. So the gradient of AB can be given by the change in y. So that one is M is our change in y. We have y plus delta y minus y all over x plus delta x minus x. So this one is y plus delta y minus y over x plus delta x minus x. And what does that give us? It will give us dy or delta y over delta x, delta y over delta x as our gradient, Now, since y is equal to fx, that means y plus delta y, that means that y plus delta y is equal to f of x plus delta x is equal to f of x plus delta x. Any slight change in y causes a corresponding change in f of x to get f of x. Therefore, delta y over delta x is equal to f of x plus delta x minus f of x all over x plus delta x minus x. Okay, whereby that one will go with that, and we have delta y over delta x as equal to f of x plus delta x minus f of x all over delta x all over delta x all over delta x. Now, since A is very close to B, A and B are coordinates on our curve. We had it. Since A and B are very close to B, then delta x approximates 0, or we can say delta x tends to. This one is approximates to 0, or this one is tends to 0. Why? Since A and B are very close. Then we can have dy dx, then delta y over delta x. This one approximates dy dx. That one approximates dy dx. Therefore, dy dx is equal to the limit as delta x tends to 0, of f of x plus delta x minus f of x all over delta x, How is this one coming about? Since A and B are very close, then delta x approximates 0. So if delta x approximates 0, delta y delta x approximates a full derivative. That full derivative is what we are calling dy dx. So the above process is the one called differentiation. And dy dx is called the gradient function of any curve. So we are saying that this process of coming up with dy dx is called differentiation. The dy dx, or the result you get by differentiating, is called the gradient function. It can also be called the derivative or derived function. We shall pick it up from there in our next lesson.